In this class, we are going to express about that homogeneous expression. So you know very well about the algebraic expressions. Algebraic expressions are many types. So in the family of algebraic expressions, homogeneous expressions and the polynomials and multinomials and cyclic expressions comes under. So let us to discuss what are the homogeneous expressions. So briefly we'll start with first algebraic expressions by taking an example. So algebraic expression, it is such an expression which involves the unknowns like xyz variables and the numbers connecting with some logical operations with any degree. For example, I am writing example for algebraic expression. You can consider it very carefully. X to the power of 6 y power minus 7 plus 5x cube and y minus 11. This is an example of algebraic expressions. Okay, so from this one only that homogeneous expressions, cyclic expressions and polynomials will come. So now we are taking only the about that homogeneous expressions. What is meant by homogeneous expressions? Homogeneous expressions are nothing but algebraic expressions which involves in the every term the degree same. I am writing an algebraic expression which involves an algebraic expression which involves degrees same in the every term. Every term of it. So let us to take one more example. Look here carefully. X to the power of 6 is there minus 7 x to the power of 5 y to the power of 1 plus 3 by 2 x to the power of 4 y square. So once you consider this expression very carefully, so what you understood from this expression? This is an algebraic expression only. So now we'll go to the terms, every term. In the first term, if I consider the degree, its degree is 6. In the second term, the degree it is 5 plus 1. Why do we add 5 and 1? Means in the second term, it is involving the two variables x and y. The degree of this monomial, it is the sum of the exponents of its various variables. So 5 plus 1, 6. In the third one also 4 plus 2 is 6. That means in this expression, every term it is having the degree 6. The degree of the first term it is 6. The degree of the second term is 6. The degree of third term is also 6. This type of expressions we call them homogeneous expressions. Now we are going to write the standard forms of homogeneous expressions. So when you are writing the standard form of homogeneous expression, we need to write as many terms possible in that expression. Every term we must write there. So now let us to take the homogeneous expressions whose degree is 1, and variables. So I am taking the variables x, only single variable here, and it's homogeneous expression general term now, standard form. So how do we write? So first degree expression we should write which involves x, right? the homogeneous expression, it is nothing but ax. So consider it very carefully. We used only the single variable x and the degree of it is 1, and this is a single term. It is a monomial homogeneous expression in x of the degree 1. So in the same way, I want to write the second degree homogeneous expression in the single variable x only. So how do you write its general form? So you have to take the highest power is 2 in the every term, like ax square power is the 2 in this term. If I write yes, there is no chance to write the remaining all the terms. This is only the general form of homogeneous expression in the single variable x. So like that, of the degree 3 in x also we can write one example. How do you write example here? Ax cube. So these are the general form of homogeneous expressions of the degree 1 which are in the single variable x. So the problem will arise if you take more than one variable to write the general form of the homogeneous expression. How do we write the general form of the homogeneous expression? We will discuss. So before that, you need to remember, so whatever the coefficients of the variable terms, they are called numerical coefficients. The numerical coefficients, you can take any type of numbers, maybe the natural numbers, whole numbers, integer, rational numbers, irrational numbers, real numbers, and the complex numbers also. So now we'll start with the degree 1. I'm taking the two variables x and y here, and I want to write the homogeneous expression of the first degree expression. So you should start with the numerical coefficient ax power 1, it is there, right? So now using the variable y also, we can write one more term by. So its degree is also 1, right? So including both variable x and y, if you write x power 1, y power 1, it will become 2. So we should not write that one. So only ax plus by, it is a homogeneous expression of degree 1 which is in the two variables will come. Now the second degree homogeneous expression in x and y, I am going to write it. So you should use the highest power in the every term, it is 2 at everywhere. Ax square plus by square. The degrees are the 2 are there in both the terms. And here also I want to take the degree 2 term, x power 1, y power 1. So here if you add this powers, degree 2 is there. So along with that one, numerical coefficient c we should take, connect with this arithmetical logical operations. So then this will be the second degree homogeneous expression in x and y. So let us to write fourth degree now. How do you write? Just think about it. So you have to take the degree 4 in the every term. So like this, ax to the power of 4. But we need to use both the values x and y at everywhere, plus by to the power of 4. So in both of them degree is of 4 and plus c. So if I decrease the power of x by 1, it will become x cube. Along with x cube, you have to take the one more variable coefficient y power 1. Then only the degree will be the 4. And plus d, x square and y square we can take, right? Degrees of 4 will come. Next, e x y to the power of 3. Here also the degree will be the 4. So these are the possible terms, all the terms of homogeneous expressions of the degree 4 which are in x and y. So now like that we can give the standard forms very easily. Now I want to write a homogeneous expression in 4 variables now, x, y, z, w also. Okay, I am taking the degree 2 here. So how do you write it? Look here, its homogeneous general form will be, I am writing here, many terms will come, ax to the power of 2. The degree is 2, we use the variable x, like that we should use the variable y. By square, second degree, cz square, and the one more variable w is a dw square. So second degree terms are written here by taking only the single variable in the every term. Now I want to take two variables also. X, y power 1 we should take. X power 1, y power 1, degree is 2 na? Plus f, x, z also we can take. Plus g, x, w also, here also degree 2. Plus h, y, z, degree is 2. Plus H, Y, W also we can take, right? Plus with Z we should write H, I next. I is the coefficient, numerical coefficient, I. Zx we can't take, already xz is over. Zy also we can't write. Zz it is over, z square term, and zw it is not there. So zw I am writing. And with w, wx, wy, and wy it is there. Wz is also there. So it's over. The last one we have to take 3 variables at a time. If I take 3 variables at a time in this expression x, y, z, you can guess its degree will be the 3. So we should not write the degree 3 term. Why? Because this is only the general form of the second degree homogeneous expression in the 4 variables x, y, z. Okay, now you should not take the degree except 2. Right. So in the next video we'll go to discuss about the cyclic expressions, and after completing that cyclic expression we'll do some problems related to the homogeneous expressions and cyclic expressions. Right. Bye, all of you.